We've been looking at the electrolysis of aqueous electrolytes. One of the things within electrolysis of aqueous electrolytes that you're going to have to know, you're going to have to understand, because you'll be asked questions about, is the electrolysis of dilute electrolytes versus concentrated electrolytes. And where you will most likely get asked about that is within the context of sodium chloride. Concentrated sodium chloride solution is sometimes called brine, and you may be asked questions about the electrolysis of brine. You may be asked about the electrolysis of dilute sodium chloride. So we're going to look at both of those and look at the comparison between them. Okay, so let's start off with electrolysis of dilute sodium chloride. We're going to set up our electrolytic cell. We have our battery, our electrodes, and our electrolyte. Remember that the electrode that's connected to the positive terminal of the battery, that's called our anode. And the electrode that's connected to the negative terminal of the battery is called our cathode. Now, in our electrolyte, we're going to have sodium ions, chloride ions, and because it's aqueous, we're also going to have hydrogen ions and hydroxide ions. And because we have two ions competing to get discharged at each electrode, what determines what will get discharged is the relative positions of the ions in the reactivity series. So for our cations, they're going to move to the cathode, Na plus and H plus, and let's check our electrochemical series and see what will get discharged. We have sodium, we have hydrogen. Hydrogen is lower down the series, so hydrogen is what will get discharged. So at the cathode, H plus ions discharged. Now, for our anode, you have Cl minus ions and OH minus ions also competing to get discharged. If you look at your series, what you'll see is that OH is below Cl, so OH is what is going to get discharged. So at your anode, OH minus ions are discharged. Okay. Now, again, there are several types of questions that you could be asked. All right. So you could be asked about what happens at each electrode in terms of the redox process. What would you observe? And you can also be asked about changes in the electrolyte. Okay, so if we consider the cathode, at the cathode, since the H plus ions are going to be discharged, you're going to have one H plus ion gaining an electron to form hydrogen. Hydrogen is not monoatomic, it's diatomic, so two hydrogen atoms are going to pair up to give you H2 gas. We can combine these two equations and we can just say 2H plus ions, which are aqueous, gain 2 moles of electrons to form H2 gas. Okay, so that's your half equation. Because you're gaining electrons here, you know that that process is, think your oil rig, oxidation is loss, reduction is gain. You know that reduction is occurring. So at your cathode, reduction is occurring. At the anode, you have your hydroxide ions being discharged. And remember, I said to you before that the hydroxide half equation is probably the only one that you may have to commit to memory. Alright, it's 4OH minus, losing 4 moles of electrons to give you 2H2O plus O2. That's gas, that's liquid, that's aqueous. Okay, so this is your half equation for the anode, and because your hydroxide ions are losing electrons, that means that oxidation is taking place. So in terms of what you'll see at the cathode, because hydrogen gas is being produced, you're going to observe effervescence at the electrode. In terms of at the anode, you're also going to observe effervescence. You're going to observe bubbles of a colorless gas because oxygen is being formed. And this can tie in with your qualitative analysis, because you can then get asked for possible ways to test for the identity of the gas. Okay? So, one other thing you can be asked is about the changes in the electrolyte. Now, in this case, because we are removing hydrogen and we are removing hydroxide, those are the ions that are getting discharged, what is happening to the electrolyte? The electrolyte is just becoming richer in sodium chloride. So it's becoming more concentrated in sodium chloride. So what will happen now if we shift gears and we look at a concentrated solution of sodium chloride? Concentrated solution of sodium chloride is special chemical. It's called brine, and brine is used in preservation of food and in packaging of food. So now we're looking at concentrated sodium chloride, otherwise known as brine. Now, just like before, we set up our electrolytic cell and we're using unreactive inert electrodes, just like before, graphite or platinum electrodes. Have our cell nicely set up with our cathode and our anode. We're going to have our same ions being present, Na plus ions, Cl minus ions from the sodium chloride, and H plus ions and OH minus ions from the water. Okay? Now, just like before, you have competition between the sodium ions and the hydrogen ions to get discharged at the cathode. Just like before, your hydrogen ion is going to become discharged because it is lower down the electrochemical series. So at your cathode, H plus ions discharged. Now, with concentrated electrolytes, there's a bit of a difference, because we would expect, based on the position of chloride and hydroxide in the electrochemical series, that hydroxide would get discharged. However, for anions, that is not the case. When you have concentrated electrolytes, the anion that is present in the greater quantity is what gets discharged. There is more chloride than hydroxide because we're dealing with a concentrated solution of sodium chloride. So there are more chloride ions than hydroxide ions. So the chloride ions are what are going to get discharged at our anode, not hydroxide. This only applies, this deviation from the electrochemical series only applies for when we have concentrated solutions. So at the anode, Cl- ions will be discharged. Okay, so you can write your ionic half equations and you will have 2H plus gaining 2 moles of electrons to give you H2 gas. And then for your anode, you're going to have 2 Cl minus losing 2 moles of electrons to give you Cl2 gas. Okay, so again you have effervescence of a gas at each electrode. However, chlorine is a very useful gas because it's used in making bleach, it's used in manufacturing cleaning products. So this is commercially useful. Another thing is that if we look at what is being removed, during the process, we're removing hydrogen and we're removing chloride. So our solution is becoming richer in sodium ions and hydroxide ions. So it's becoming richer in sodium hydroxide. It's becoming richer in that alkaline compound. Sodium hydroxide is extremely useful in making a wide variety of products. Okay, so this is an important industrial process. The electrolysis of concentrated sodium hydroxide, the electrolysis of brine, is an important industrial process. It allows us to manufacture hydrogen gas, chlorine gas, as well as sodium hydroxide. 3 very important chemicals. Hydrogen can be used as a fuel. Chlorine is used as in the manufacture of cleaning agents, and sodium hydroxide is used in a wide variety of things, making soaps and shampoos, making hair treatments, wide variety of chemicals, compounds. Okay, so note the difference when we were carrying out electrolysis of a dilute solution. We abided by the electrochemical series for both cations and anions. However, for the concentrated electrolyte, the anions do not abide by the electrochemical series. The anion that is present in the greater amount is what is discharged preferentially. And that's the takeaway from this lesson.